So this is Note-Taking Guide 6.8, and what we're doing today is we're going to compare functions. And what I'm going to do on today's assignment, as well as the note-taking guide, is I'm going to give you some functions in different forms. So right here is our first set of functions. It says there's 4 different functions here. This one's in graph form. This one's in a t-table form, like ordered pair form. This is the equation of the third function. And the fourth function says the slope is 2 and the y-intercept is 1. Could you write an equation for this if you wanted to? Pretty easily, right? Could you graph these if you wanted to? Pretty easily to see what it looks like. You could graph this if you wanted to also, or you could put it in ordered pair form. So really what this is 4 different functions in 4 different forms. And what you're going to have to do today is to compare the functions and answer questions. So number 1 says which of these functions graphs has the least steep slope. So if we were looking at the slope of these, we would be looking to see which one climbs the slowest. Does that make sense? So how can you tell which one of these functions would have the least steep slope? Anybody have an idea? I can totally count the slope on this one, can't I? What's my rise over my run? Remembering I always have to run to the right. Yeah, down 1 over 1, right? So my slope of this line would be a -1. Do I know the slope of this line? Yeah, my slope here is 5. Do I know the slope of this function? It tells me it, right? My slope is 2. So the only one that I can't see the slope on is this set of ordered pairs. Does anybody have an idea how we could find the slope on that? I can think of more than one way, so don't be afraid to kind of just blurt out what you think. What'd you say?
-4.
Why do you think -4? Okay, so you just compared your y's and your x's together, didn't you? Yeah. Does anybody remember that when we did that, that was called the slope formula? And we did y2 minus y1 over x2 minus x1. So what Austin really just did there was he subtracted his y's and he looked at his change in x's also. And he just kind of plugged it through the slope formula, but without really doing the work behind it because he just did it in his head. But let's just throw this through the slope formula. Let's say this is y1 and y2, x1 and x2. Because if I put it through the slope formula, then I'd have the slope of this line. So I would do 2 minus 6 over -1 minus -2. And I could just solve that. Probably if I would have done that in the other order, it would have been nicer with the negatives, right? But it doesn't matter. It works out the same way. On the top, I'd have -4. On the bottom, that minus and negative changes to plus. So I'd have a +1 on the bottom. So the slope of this line is -4. Okay, so then back to the question. How can I tell which one of these functions has the least steep graph? I don't really like how that's worded, but that's the way that it's worded on the computer program. So which one grows the slowest, right? It would, like if you're talking about least steep and you had a line that looked like this, and we called that line A, and you had a line that looked like this, which was line B, which one would be the least steep? It would be A, right? Because it goes up slower than B goes up. So how would you get one that goes up slower? What would that number look like compared to the other numbers? Would it be a smaller number? What about dealing with positive and negatives? What do you think about that? Will that make a difference in how my slope is steep, the steepness of my slope? Actually, the positive negative just tells me a direction of the slope, right? So if we looked at the number and not so much at the positive or negative, we could compare to see which one was the least steep. If you're still confused though on that, You could graph all of these other three on this graph over here to see which one has the slope that grows the slowest. But which one do you think it is? Is it -1, +5, 2, or -4? Which one would have the least steep graph? Anybody have a guess on that? Nobody wants to make a guess? Okay, so that's a good point to bring it up, because you're like, well, what about the y-intercept? Does it matter where it crosses? We're really literally just going to count the slope. So if this one was down 1 and over 1, let's graph them on the same graph to see, because I can see you guys are not visualizing what's happening with the graphs yet. So on this one right here, we know when x is 0, y is -2. Do you guys agree with me on that? So we could go 0, -2, which is right here. And we could follow our slope, or we could graph another ordered pair. We could go 1, -6. We could go 2, -10. Oh, I'm down one too many. And we could graph that line, right? This would be the line for function 2. So I'm just going to label it function 2. I'm going to label this function 1 so we don't forget, okay? So looking at function 2 and function 1, which one is least steep? Which one travels the slowest? Function 1? Is that what you said? Okay, I agree with you on that. Okay, it's traveling slowly compared to this one. So let's look at the numbers to compare. This one had a slope of -1. This one had a slope of -4. So the bigger number, remember we're not going to talk about signs, but the bigger number had a steeper slope. Okay, so this number is 5. Would it be steeper than this one that we just graphed? Yeah. And what about 2? Would 2 be steeper than this one? No, it would be less steep than this one, right? So could you tell me, out of these 4 graphs right now, which one has the least steep slope? Function 1, because its slope is the smallest. You're right. Nice job. There's lots of ways you could have looked at that to figure that out. Maybe you have a way that you would have liked better. I think maybe if I were to do it, I would have just graphed them all real fast and saw which one moved up the slowest. Okay? All right, number 2 says, which function has the greatest y-intercept? Well, the y-intercept is where your graph crosses the y-axis. So looking over here at function 1 crosses at 5. Okay? So I'm going to say y equals 5 is my y-intercept. Do you guys agree with me on that? That ordered pair would actually be 0, 5, because you're over 0 and you're up 5. So function 1's y-intercept is 5. Does anybody know what function 2's y-intercept is? It's -2, right? Because we already graphed it. But you can always tell where your x is 0 is your y-intercept. So this function's intercept is at y equals -2 for my y-intercept. Does anybody know what this graph's y-intercept is? Yeah, it's y equals -4. And then this one says it's 1. So it says, which function has the greatest y-intercept? Which one had the biggest number for its y-intercept? Function 1. Okay, so you would say function 1. All right, and then the last question to do with these ones says, which functions have graphs with slopes less than -4? So let's just look at them. Is 5, oh wait, where's my slope on this one? Is -1 less than -4? No, so that one doesn't fit, right? My slope on this one is -4. Is -4 less than -4? No, so that one doesn't work either. The slope on this one is 5. Is 5 less than -4? No, so that slope doesn't work either. My slope here is 2. Is 2 less than -4? No. So did any of the functions have a slope less than -4? No, so I would just put, either you could put none, or you could put this, which means no solution, right? So sometimes you're still going to have no answer when you're comparing those functions. Okay, these were all lines. They were all compared together as lines. Now we're going to look at two functions that are parabolas. They have the power of 2, and I know that they're parabolas. And mostly I know that because of the way the questioning starts over here. It says, what is the vertex of function 1? And what is the vertex of function 2? Okay. Does anybody remember how we can find the vertex of a function when it's in standard form? Anybody remember a worksheet several weeks ago that said to find the opposite of b over 2a? That would give you that line of symmetry. Then you could substitute it back in to find the vertex point. So we're going to do the opposite of b over 2a. This is my b value. The opposite of a -16 would be a +16. And then I'd have 2 times my a value. And what's my a value? It's 2. So I'd have 16 over 4. So my value is 4. Then I'm going to substitute it back in over here because this was my x value. I'm going to substitute it back in to find my y value. So I'm going to have 2 times 4 squared minus 16 times 4 plus 39. And you're just going to punch that in your calculator to find the second part of your ordered pair for your solution. So 4 comma whatever that number is. So this would be 2 times 16 minus 64 plus 39. But your calculator will do all that work from the very beginning if you punch it in exactly the way I have it written.
7.
It is 7. Nice job. So this is my vertex point. Okay, my vertex point is 4, 7 on this. Okay, so it says what's the vertex point of function 1? The vertex point is 4 comma 7. Then it says what's the vertex point of function 2? Well, we know this is a parabola. So we know at some point there's going to be a point that breaks it up into go in both directions, right? It might be easier on this to just graph it really fast so you can maybe see where the vertex point is. So I'm just going to throw myself a graph on here really fast. And it's not going to be perfect because I'm just doing it really fast to see if I can find where my vertex point is. And I might not even have enough space to do this, but let's look and see. We'd be a -8 and 13. So 1, 2, 3, 4, 5, 6, 7, 8. And then I'm up here at 13. So I'm like clear up here. Then I'd be -6 and 7. Which is like right here. -4 and 5. -2 and 7. Oh my goodness, did we just find a vertex point? Because remember, the vertex point is where you change direction. So guess what we just found right there? Our vertex point, right? What ordered pair was that we changed directions at right there?
-4, 5.
Yeah. So -4, 5. Okay. I want to show you how I can see it on my graph. Do you see how at -4, 5, the ordered pairs on either side of it had the same y value? And then the next ones out had the same y value? Do you see how you can find the vertex point by looking at the y values? Because parabolas have symmetry, right? They're the same on both sides of the vertex point. So it's kind of easy to see where that's happening at if you have those ordered pairs listed. Okay, It says which function has the smaller minimum value. So let's talk about minimum value for just a minute. Our minimum is our vertex point on these, right? Because remember, minimums have to be at the bottom of the valley. So when we put 4 in this vertex point, I got 7 out. When I put -4 in, I got 7 out. So this would be my value of my minimum. Over here, when I put 4 in, I got 7 out. So which one has the smaller vertex point or the smaller minimum, it says? Actually, neither of them do, right? They're the same. Oh, wait, did I write that wrong? I take that back. What was this vertex point? I wrote 7, but it's not 7. We said it was -4, 5, right? So which of these outputs is smaller? The 5 is smaller, right? So function 2 has the smaller minimum. And then it says what is its minimum value? Its minimum value is 5.